Alright, last week when I went to light my hydroxy barbecue that I'm making, uh, everything was working good. Then I looked over and I noticed foam for the first time in a couple of months. Foam had started shooting out these hoses and started coming out my hose and coming down, so I had to turn it off. So I went and reached for my foam free, which I haven't used in a couple of months because I haven't had to, but just as I went to reach for it, I remembered somebody sending me a video where a guy had figured out that if you put cutoff valves in line with the water line that feeds the dry cell, and you slowly choke off the water flow so that it restricts how much water is going to your dry cell, and have an amp probe, clamp on amp meter like that, attached on, you'll notice as you're turning it slowly, you're going to hit a spot where the amperage increases, and then once you turn it just a little bit past that, you'll see it'll decrease again. So you want to leave it right where the amperage goes up. And for this guy anyway, when he did that, when he was choking off the dry cells, he was actually able to get rid of his foam, and he increased the amperage in production a little bit just by doing that. So I decided I was going to try that before I jumped to the foam free, and I installed the two cutoff valves over the weekend, and when I was fine tuning it yesterday, I noticed it does increase the amperage. It does increase the production just slightly. I gained like maybe another 8 milliliters of gas. Very, very hard to measure, but there is a slight increase. You probably notice it more on higher productions. But the one thing it didn't do for me was stop the foam. Yeah, the foam just continued to go. So I went back to the foam free instead. But I just wanted to let you know, if you guys come across that video and you wonder if the choking off the flow to the dry cell works, it may work, but it did not work for me. What it did do was increase the flow and the amperage that the cell pulls. It went from, let's say, the diamond cell here, which was at about 18 amps, went up about 3 amps to about 21 amps. This one that was at 8 amps went to about 11 amps by choking it off. And I don't see much production actually, so I don't even think there's much of a gain in it anyway. Alright, so the choke off valves are good for adding a little bit more production. That's about it though. I didn't find it did much for the foaming, but I did put my foam free in there as soon as it started foaming again, and about 2 seconds later there was no foam. It's unbelievable how good this stuff works. It's just crazy. Actually, I'll turn it on right now without even stopping the camera, just so you can see there's no foam in those lines now. Let's see. Let's see this here. You see how clear that water is now? This one, same thing. Product foam free is actually unbelievable. Alright, I just wanted to show something. I'm working on my barbecue here. I'll show the results once I'm finished it. It's looking pretty good so far, but what I was wanting to say was, in the line right after the ball valve, even though I got a back flame arrestor here, right after the cutoff valve, I've inserted a MIG tip right into the tube itself, and boy does that ever work perfect. When I shut this off, it does flash back. The gas flashes right through, and I could see the blue streak stopping right at the MIG tip. It doesn't even flash to the back flame arrestor. So as long as you got a small tip like a .023 like I got, you should have no problem arresting a backflash. Just with a MIG tip inserted right into the tube. This MIG tip fits right into a 1/4 inch tube. It is a different MIG tip than probably most of you guys are using. The standard ones are a little smaller, but just go to a welding shop and ask for the Miller MIG tips, and those are much better quality, and they're a little bigger. Anyway, just wanted to let you know that. Alright, so I decided I wanted to try boiling some water again, but this time I wanted to use a big flat circular piece of metal that I had, hoping that the heat will distribute evenly around it. You'll see that I don't have much patience with it, and it turns into an experiment where we can see how close we can get the pot to the flame. Where are we here? There's the flame hitting the bottom of this piece of metal. We're going to see how the metal will transfer the heat to the pot. That's it. Alright. It's only been a minute. I think this is going to work, because when I touch this metal, it's already nice and warm. It's actually to the point where I can't really leave my hand on it very long. Let's check in another minute. Okay, so I took the metal piece off. It was working, but not as fast as I had wanted it to work. So this experiment has turned into how close can we get the pot to the flame without destroying the pot. It's much closer than the last video that I did this, so we'll see. It's only been a minute, but I'm getting impatient, so I want to check and see. Oh yeah, I got bubbles already. I guess this is gonna happen faster than the last video because it's closer to the flame, and I don't see any destruction of that metal yet. This is actually pretty good. Check in another minute. Alright. Still no destruction of the pot, I should say. It's been another minute. This almost tells me that I could get about an inch closer maybe, or half an inch anyway, without any more wrecking. We'll try that in the future. Let's see where we're at after this minute has passed. Oh yeah, we're just starting to boil now. Next minute will definitely be boiling. Alright, let's check it again. A lot of people are asking me why I'm staying with the one single burner as opposed to a bunch. For my barbecue idea, yeah, definitely there's got to be more than one burner, but for the boiling water application, I want to exhaust every experiment I can with just a single thicker flame like this to see if that can be used to cook with more efficiently than a bunch of little tiny flames. I still have no idea which one's going to be better, but I want to exhaust all the experiments I can with this thick flame before I go and spread it out into little ones. Anyway, let's see where we're at here. It must be boiling now. Oh yeah. She's good. Alright, so just like last time, we were able to boil the water fairly quickly with hydroxy gas. This one went probably a minute or two quicker than the other way, but I'm happy with the results. I'm actually going to put it a little bit closer next time. I'm going to not do that today, but next time I get a chance, I'm going to do the same experiment and bring the flame even closer to the pot, because there's no destruction of the pot at all. Let's take a look at that first before I shut it off. Pot is perfect underneath. There's tons of steam coming out, as you can see, which means we're boiling. Yay. Alright.